Hi guys, in this video we are going to be looking at something very interesting and that is going to be very important as well. It's motion and time. This is for science term 1 portions for my school and it will be useful for students of my grade. And most probably it will be useful for all 7th graders. Okay guys, let's start with our topic motion and time. So first of all, let's like the heading. Let's start with what is the distance and what is the displacement. The basic difference between distance and displacement. So basically when we look at distance, it is the total movement of an object without any regard to direction. I'll explain you guys about this. And displacement, the shortest distance between the starting and the ending point. This is for the definitions for your note. You keep note of all your definitions. These are very important. So let me repeat once again for you guys. Distance is the total movement of an object without any regard to direction. Displacement is the shortest distance between the starting and the ending point. So basically, let's see what's the difference between distance and displacement in this case. So let's see what's distance. So for instance, we have a classroom 1. So this is the starting point. Let's name it SP, and this is the ending point. Let's name it EP. So the distance in this case would be you're walking here, and after that you'll be coming here. This is the distance. This is the distance. But when we look at displacement, let's draw a similar classroom. This is classroom 2. So this is starting point and this is ending point. So this could be the shortest path between the starting and the ending point. So here in this case, it will be 100 meter here, 150 meter here and 100 meter here. So 100 plus 100 plus 150. In this case, it will be 350 meter, the distance. But in this case, when we look at the displacement, it's just 100 meter. It is going to be 100 meter. So this is the actual path and this is the shortest path. Hope you guys understood what is displacement and distance. Let's see some important formulas now. So distance is equal to speed into time. So like in which we have speed is equal to distance by time and time is equal to distance by speed. This can be seen with the help of a formula triangle. This is distance, this is speed and this is time. So distance is equal to speed into time. We see. So distance is equal to speed into time. Now speed is equal to distance by time and time is equal to distance divided by speed. This is what we call as the formula triangle. And now next in case we are going to be looking at some important formulas in this lesson. And after that we have acceleration. Acceleration is not given in our textbooks, but let us note it down. Acceleration is equal to ending velocity minus initial velocity by time taken. Now after that we have velocity. Velocity is displacement by time, and after that we have average speed. Yeah guys, these are some important formulas we have for this lesson. So I think that's all with the formulas. Next we'll be looking at the different types of motion. Let's look at rectilinear and periodic motion. Rectilinear motion is the motion in a straight line and periodic motion is the to and fro motion which happens between regular intervals. And now let's look at uniform motion and non-uniform motion as well. Uniform motion is on the type of motion which repeats itself in regular intervals of time. And when we look at non-uniform motion, it has a constant. It doesn't have a constant speed, and it does not repeat itself in regular intervals of time. For example, the motion of a moving car, it might go in 40 kilometers per hour, but due to traffic, it might go to 20 kilometers per hour. Due to a traffic signal, it stops. So these are the cases. Okay guys, let's look at some laws. When the initial and the final velocity is the same, the displacement is 0. So for example, in this case, let's draw a circular path. This is the starting point. So you run around this field for 100 meters, and when you reach the same point in here, the distance of this, let's say this is about 1 kilometer radius. So the distance is equal to 1 kilometer, but displacement is equal to 0. Yeah, you guys see, when the initial and the starting point is the same, what would be the cause? What would be the largest distance between the initial and the final point? What could it be? There couldn't be anything. So, okay guys, let's start with graphs. 1 second, I'll rub the board. Graph, we have 3 types of graphs. Pie chart. And we also have bar graph. And line graph. Let's draw a circle. And the most common example we all know, just by looking at it without even naming it, we know this. 78%, 21%, and 1%. This is composition of air. Now let's look at bar graph. Bar graph, we have 0. We have x-axis, y-axis, and there are bar-like stuff. And this is 1, 2, 3, and this is 1, 2, 3, 4. This is a simple bar graph. Let's look at line graph, and in this case, let's look at the representations of probability of points. Don't mind my drawing, I'm just doing a freehand sketch, so it wouldn't be that perfect. This is just something rough. This is what we call as origin. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And what we do in this case is probabilities. We have a I forgot to write the equation in this case. Example, x plus y is equal to 6 minus 1, which is 5. Sorry, this is 7 minus 1, which is equal to 6. This is the equation, and this is the probability of what could happen. 4, 2, 3, 3, 3, 4, 2, 5, 1. This could be the possible stuff. And when we look at the next, we are going to be looking at the interpretations of bar graph. Let me not waste time by doing all these graphs, so let me show you guys all these graphs. And let me tell you guys, this is my notes, what I study. I usually write all these in my notes, and that's what I'm referring to make my videos. And these are 2 types of graphs. Now let's start with speed. We're going to be looking at distance time graph now. We're going to be looking at 4 different time graphs. This is origin, and this line is a straight line, guys. Just okay. This represents constant speed, and this represents rest. Okay. This is rest. Sorry, I forgot to plot the axis. And this is going to be this is a non-uniform motion. And finally, let's look at the graph with uniform motion, which is constant speed itself. So I hope you guys understood the 3 types of distance time graphs. And now, okay, we're just going to be looking at speed, and we're going to be winding up now. So speed is basically the rate of change of motion. Speed is measured by speedometer, while distance is measured by odometer. The distance traveled in regular intervals of time is called as speed. So I hope you guys understood about the topic motion and time. We are going to be looking at other important terms for this topic in our future video. So I'm going to be see you all tomorrow in a new video. I'll see you all. Bye. See you later. Bye.